Hi guys, so in this video we're going to create a simple actor component using C++, and all the actor component is going to do is make any actor that it's applied to spin around and bob up and down on the spot like these two actors in front of me are doing. Now, as I said, the actor component itself is going to be C++, but then you can apply that component to any actor, whether it's C++ or Blueprint, which is what's happening here. So this spinning thing on the left is a C++ actor, and this one on the right is a Blueprint actor. So we'll see how you work with both. But as I said, the component itself is C++. Okay, so let's get started. Right, to begin with then, let's go File, New C++ class. It's an actor component that we want. And I'm just going to call this something like AC for actor component underscore spin and bob, and just hit create class on that. And then that'll take a second to compile. Once that's done, I'll see you over in Visual Studio. Okay, so here we have our new CPP and header file. Over in the header file, we're going to add a few variables that we need to get our effect to work. So first, let's deal with the spinning. For that, we will use a rotator rather than just a simple float. The reason is we can then specify to spin around any axis we want, or any combination of axes, rather than just the one. For bobbing, we'll use a vector. Again, same logic. If we use a vector rather than a float, we can choose to bob in any direction we like. And because of the way we're going to implement bobbing up and down using a sine wave, we may want to be able to effectively multiply up the frequency of that sine wave to make us bob faster or slower. So we're going to add a float here called bob speed multiplier, and you'll see how that gets worked within the CPP. Now, because we want to be able to edit these three things inside of Unreal, we want some uProperty tags above them. I'm just going to go for the simple edit anywhere, blueprint read write, and we'll make a category for these called something like settings, just so our stuff is separate to the stuff that's built in. And we're going to want that above all three of these things. So if we duplicate that line and just copy it down, there we go. Now, because of the way that we are going to implement the bobbing effect, we also want a private variable which stores where did what was the start location of the actor that this component is attached to. The reason is, if we just add this, so start location. I mean, there are a couple of ways to do this. The way I'm going to do it is each tick, work out how far from start location should we be given these two variables, and then just add that onto this, basically. Right, so that's all we need in the header file. What we need to do now is just set the value of this in begin play, and then work with these three in the tick function. So begin play, we can go start location is get owner. So get owner is something that's built into actor components, and it just basically gets the actor that this component is attached to. And then from there we can do it get actor location. It seems to want to put a complaint here as though it doesn't know what actor is. I think you can get that around that with a hash include game framework / actor. But that said, it might work fine without. See, so no, that's not a problem. A word about that. So yeah, Visual Studio, as I've mentioned before, does tend to put a lot of red pen everywhere, even when there are no errors. Now, what I'm using here, this plugin called Visual Assist, which is why this looks a little bit different to maybe how you've got it set up, does deal with a lot of that for you. But I will do a video, maybe the one after this, showing you how to set up Visual Studio properly to have IntelliSense work and all that good stuff. Right, so now the tick function, tick component even. So we can deal with rotation first because that's so easy. All our rotation is get the owner again, the thing this is attached to, and we need to do an add actor world rotation, and all it's going to be is our spin rotator multiplied by delta time, so that everything moves nice and smooth no matter what the frame. Well, we move at the same rate no matter what the frame rate is. Now for our bob effect, it's a little bit more involved, but not by too much. We can use a sine wave to get the effect to look good, so we'll go float time. To do a sine wave, we need time basically. And what we want here is the amount of time, sorry, get owner, that's elapsed since the level loaded, because we can just run that through a sine wave function and get a nice, -1 to +1 output from that. So if we do a get owner, get world, get real time seconds, that returns you in seconds as a float how long since the level started. Underneath that, we can then do the sine wave function. So float sine is going to be the math library sine function, and it's going to be whatever time in seconds was multiplied by our bob speed multiplier. And what will come out of this is a value between -1 and +1, which we will use to sort of drive our bobbing effect, where if this was 0, we would be exactly at the start location. If it's 1, we'll kind of be at the top of the bob, if that makes sense, and -1 would be at the bottom of it, and we'll just keep on going up and down like a sine wave way. Okay, so let's apply that then. So we want get owner. If I can type, get owner, and we want set actor location, and it's going to be start location plus the bob vector that we set up multiplied by the output from that sine function. Like I say, there are other ways to do this. Like, if you didn't want to mess around with having this, you could just get the actor's location on each tick, work out what the difference is between last frame and this frame in terms of its position, and then just add that on and reset it. But I think this is less code. That's all this needs to do. So what we're going to do now is head back over into Unreal, hit compile, and just wait while that does its thing. So our compile is complete. There were no errors, but we don't yet have an actor to attach this to. So the actor component that you can see here, as the name suggests, it needs an actor to be attached to, and then that is the thing that will spin and bob up and down. So first of all, we'll use a C++ actor, then we'll come back and do it in Blueprint. So File, New C++ class. This time we're making an actor, not an actor component, and we'll call this something like my CPP actor. It's not very imaginative, I know, but that'll do. Hit Create Class, and then again, we'll just need to wait a few seconds while it compiles all this. And here we are with our new header and CPP file for our actor. Now this is going to be dead simple. All it really is a container for two components. We want a static mesh component so that we can see this thing in the world. So use static mesh component mesh, and we want our own component, the spin and bob. Now one thing you may not have noticed, we called it AC spin and bob, and Unreal's automatically added the U in front of it, which it will do for anything that doesn't inherit from actor, basically. If we inherited from actor, we would get an A in front of the name. So here you can see my CPP actor is actually now called a my CPP actor. It's just something to bear in mind. So here we want a pointer of type UAC spin and bob, and we'll call that just spin and bob, why not? And that will need either including or forward declaring. We'll do it as an include for now. So that's that. And then the CPP, all this needs to do is create those two components. So mesh is going to be create default subobject. It is a static mesh component, and we can just call that mesh. And then the spin bob, what look at spin and bob, yeah, there we are, is exactly the same idea. Create default subobject. It's a UAC spin and bob, and that will just be called spin bob. Okay, and that's that. All we need to do now then is head over to Unreal, hit compile, and then what we can do here is, wait, no, there's one thing I've forgotten to do, isn't there? We'll leave that compiling. If we go back into Visual Studio though, these two need to have U properties above them because we want to be able to set those from inside the editor. So the fastest thing to do here is just, I suppose, copy that line back into here, paste that in there, and paste that in there, save that, and then when Unreal's finished compiling, which it has done, we'll hit compile again to bring those two extra lines into account. If we hadn't left those, if I hadn't put those in there, when we drag this myCPP actor into the world, we wouldn't be able to see the mesh or the spin bob components so as to be able to do anything with them. So we'll let that just build, and then we'll test out this CPP actor, then go through, we won't create the component again, that's already done, but we'll create a blueprint actor and use the component in that. Right, so drag our CPP actor in, that's there. At the moment we can't see anything because it doesn't have a mesh, so we'll go over to its mesh component here, static mesh, and we'll use these two little pyramid meshes I've been using. Got quad pyramid and tri pyramid. We'll use quad pyramid for this, so there we are. That's a little big, so I'm going to go in transform for the mesh and halve all of its size values so it comes down to 0.5, 0.5, 0.5. And that's it for the mesh. So another spin bob component in its settings category. We can set a spin rate, so I'm going to go spin rate on Z of 50, bob again on Z so it goes up and down maybe 20, and the bob speed multiplier will say 5. And then if I just play this, you can see that's doing its thing. So that's quite happy spinning around, bobbing up and down, and you can change the values to get it to spin faster or on different axes, or to bob up and down faster or move in different directions. Okay, so coming out of that, now how would you use your components in Blueprints? Because sometimes that's worth doing. As I've said previously, you don't want to get stuck into using just C++ or just Blueprint. There's, you can use both. They're both good at what they do. So to use our actor component in a blueprint, we'd go new blueprint class. The blueprint is going to be an actor, and we can call this one my BP actor. Why not? Then in my BP actor, if we just dock this to the top, we can go add component static mesh. We can go add component, what do we call it? AC, was it AC spin component? Spin and bob, there it is. AC underscore spin and bob. We will drag static mesh to make it the default root, hit compile, and then we can do the same thing. So we can go into the static mesh component, say which mesh we want to use. So I'll use the other pyramid this time, triangle pyramid. Again, that's a little big, so let's halve all of its size values. And then the spin and bob, exactly as we were doing with our C++ actor, we can now set some values for what we want this to be doing. What should we say? So we have a spin much faster, say 300, and we'll have a bob on a different axis of 100, and put the speed multiplier on 2 this time. Compile that, save, and let's see how this looks. So if we drag the BP actor in, see what I mean? So that's now moving backwards and forwards along what I assume is the world x-axis. I could be wrong. And our C++ actor is still happily bobbing up and down. Right, so that's just a basic instruction to how you can create actor components, and that they can then be used in either C++ or Blueprint actors. One thing to bear in mind, I'm pretty sure that actor components themselves can't contain other actor components. So you couldn't create an actor component and then have a static mesh component inside that, I think. If you did need to do something like that, you wouldn't use an actor component, you'd have what's called a child actor. But we can cover that in a different video if we need to. Anyway, that's actor components, and I'll see you guys next time.